Our next unit is 7.EE.4C. Now we're going to take the basic solving of equations and now do multi-step equations and word problems that lead to multi-step equations. Solving multi-step equations, the goal is still the same. Isolate the variable or get it by itself and solve the mystery. Undo everything until you figure out what it is. There are just a little bit few more steps to follow. Copy down this example. As a reminder of what to undo first, let's backtrack. So in this example, we would start with our x. I'm going to put it right there. And we would multiply it by 3. Remember, we're doing order of operations this way. So in that direction, I'm doing PEMDAS. Multiply by the 3, and then add the 4, and then multiply by the 4 outside, and then subtract 18 to get 82. Now we're going to undo everything. Going this way, I would add 18 to get 100. I would then divide by 4 and get 25. I would then subtract 4 and get 21. And then I would divide by 3 and get x equals 7. That's our answer. Now what would happen if we just did the algebra, meaning none of the boxes, but still did the backtracking, the undoing of what we see? So first we would add 18, like we did on the last slide. This is the same problem. Negative 18 plus 18 is 0. Bring down, we have 4, 3x plus 4 equals 100. Then we can divide by 4. We're left with 3x plus 4 equals 25. Then we would subtract 4. 4 minus 4 is 0. 3x equals 21. And then we would divide by 3, and x would equal 7. Now here's a new problem. What should we do first? Well, we can divide by the negative 2. Get rid of that. It's 5r minus 10 equals negative 20 divided by negative 2 is a positive 10. Then we would add 10 to both sides. Negative 10 plus 10 is 0. 5r equals 20. And then divide by 5. r equals 4. What if we started by distributing first? I mean, I see distribution in the problem, so what happens if I do that instead? So I'm going to do add the opposite. I am going to do it this time first just because I see there's another negative and I don't want to get confused. And then I'm going to distribute. The negative 2 times 5r is negative 10r plus negative 2 times negative 10 is positive 20 equals negative 20. I'm going to subtract 20. Negative 10r equals, and remember that this is negative 20 minus 20. So if I did add the opposite there, it'd be negative 20 plus negative 20, which is negative 40. And then negative 10 divided by negative 10, r equals 4. Same answer. Maybe a little bit bigger numbers, but still gets you the same answer. Now what about this problem? What should we do? Should we divide by the 8 to both sides first, or should we distribute? I mean, we just saw that both ways work. So let's see what happens. If I do the divide by 8 first, I get 15 divided by 8 which is going to give me a not fun number. It's going to give me some decimals or fractions. I'm not going to want to work with those in the problem. So instead, I'm going to get rid of that, and this would be the time that you would rather distribute. You get to make the choice. Do it when it's easier. So I am going to distribute 8 times r is 8r, minus 8 times 7 is 56, equals 15. Now I just undo. I'm going to add 56 first, because negative 56 plus 56 is 0. 8r equals 71. And now I'm going to divide by 8. Now I will get r equals, and now this is where I'm going to get a decimal or a fraction answer, and that's okay at the end of the problem. I just don't want to have to be adding and subtracting and multiplying with that fraction at the beginning of the problem. So when you get to here, I really recommend that you leave things in fractions. It's better than doing them to decimals. You'll understand them better. So 8 can go into 71 8 times. That's 64. 71 minus 64 is 7. So 8 and 7/8. So 8 wholes and 7/8 of another whole is what you're looking at. Much easier to understand than the decimal. If I did the decimal, I would have gotten 8.875, which who can make sense of that sometimes? So prefer to write them as fractions.